In this video we have to see derivative by method of first principle. So, what is the method of first principle in the derivative? This is the lengthy method to solve examples, and to solve these examples by this method there is one formula, that is f dash of x equals to limit h tends to 0 f of x plus h minus f of x divided by h. This is the formula that we have to use to solve, to find answer. Let's start the exercise 9.1. Now, in exercise 9.1 we have first question: find the derivative of the following by method of first principle, and we have to use this formula. And the first question is x square plus 3x plus 1. First example, x square plus 3x plus 1. This is the first question, and that we have to solve by the method of first principle. So, this is the f of x. F of x equals to x square plus 3x plus 1, and f of x plus h, just we have to put x plus h at x, that is equals to x plus h bracket square plus 3 x plus h plus 1, and on solving this apply a plus b bracket square, that is x square plus h square plus 2 hx plus 3x plus 3h plus 1. This is the f of x plus h. Now, by the first principle, we have this formula to solve differentiation, that is f dash of x equals to limit h tends to 0 f of x plus h minus f of x divided by h, which is equals to limit h tends to 0, then f of x plus h, that is this term, that is equals to h square plus h square plus 2 hx plus 3x plus 3h plus 1, and minus f of x. First we have to multiply this term by minus, then we will get minus x square minus 3x and then minus 1 divided by h. Now, here x square minus x square will get cancelled, 3x minus 3x also will get cancelled, plus 1 minus 1 also will get cancelled, and here h will get common, h limit h tends to 0 h plus 2x plus 3 divided by h, and after that h will be cancelled, then limit h tends to 0, h plus 2x plus 3. Here h tends to 0, therefore answer will be f dash of x equals to 2x plus 3. The next example is e raised to 2x plus 1. If we apply the formula on this, that is exponential formula, then we will get the its answer in just a second, that is 2 e raised to 2x plus 1. This is the final answer of this question if we apply formula on this, but we have to solve this example by the method of first principle. So that's f of x equals to e raised to 2x plus 1, and f of x plus h equals to e raised to 2x plus h plus 1. Now we have this formula. Put these values, f dash of x equals to limit h tends to 0, f of x plus h, that is e raised to 2x plus 2h plus 1, e raised to 2x plus 2h plus 1 minus e raised to 2x plus 1, e raised to 2x plus 1 divided by h. Now e raised to 2x plus 1 will get common, limit h tends to 0, e raised to 2x plus 1, this is the common, and then e raised to 2h minus 1, this is the remaining part. If you multiply these two terms, then we will get this whole term. Then separate the limit h tends to 0, e raised to 2x plus 1 into limit h tends to 0, e raised to 2h minus 1 divided by h. We can write here or here h. Now we have to adjust this term as the formula. If we adjust here 2, then its value becomes 0, sorry, its value becomes 1, that is we have the formula limit h tends to 0, e raised to 2h minus 1 divided by 2h, which is equals to 1. This is the formula that we have to apply here. Then limit will be cancelled and e raised to 2x plus 1 into 2 and which is equals to 2 e raised to 2x plus 1, that is f dash of x. If we use formula to solve this example, we can solve just in second, but if we use first principle, then we have to solve this by this method. 3 raised to x. Here we can also use formula, and by using formula we can find its answer in just second. That final answer is 3 raised to x and log 3. This is the final answer of this question, but we have to solve this by first principle, and that is lengthy method. Here f of x equals to 3 raised to x and f dash of f of x plus h (3 raised to x plus h). Now, by the first principle, f dash of x equals to limit h tends to 0 f of x plus h minus f of x divided by h. Limit h tends to 0 f of x plus h, that is 3 raised to x plus h, minus f of x is 3 raised to x divided by h. Now 3 raised to x will get common, limit h tends to 0, 3 raised to x common, 3 raised to x raised to h minus 1 divided by h. Now separate the limit. Limit h tends to 0, 3 raised to x into limit h tends to 0, 3 raised to h minus 1 divided by h, and we have to use here as limit h tends to 0, 3 raised to h minus 1 divided by h, which is equals to log 3, which is log 3. Here that therefore 3 raised to x into its value log 3, because h tends to 0, h not equals to 0.